Hello students, now let me explain what forced vibration is. Okay, let me define it first. The vibrations of a body which takes place under the influence of an external periodic force acting on it are called forced vibrations. So this is a little different vibrations in which the body vibrates under the influence of an external periodic force. So there is a periodic force which is actually helping the body to vibrate. Okay, so the body executing forced vibrations has is acted upon by three forces. First is the restoring force, obviously the force which actually causes the body to vibrate. Second is the frictional force, which is the resistive force which opposes the motion of vibration. And the third is the external periodic force. The external force is not any other force, but it is a periodic force. That means this periodic force will make the body move to and fro periodically. Okay, that's what is the periodic force. So when an external periodic force is applied on a vibrating body, then the body doesn't vibrate with the natural frequency, but it will acquire the frequency of the external periodic force. Hence it will vary with the frequency of external periodic force. This external periodic force is also called the driving force. Okay, now the amplitude of the forced vibrations depend upon one factor. It depends upon the frequency of the external periodic force. As you know, external force is a periodic in nature, therefore this external force has a particular frequency, and the vibrations, the amplitude of forced vibrations depend upon the frequency of this external periodic force. So whenever the external periodic frequency of the external periodic force matches with the natural frequency of the body, that then the amplitude of the forced vibration becomes maximum. Okay, whenever the natural frequency of the body is equal to the frequency of the external force, the amplitude of the vibrations become maximum. That is called the resonance. Okay, that phenomena is called resonance. So whenever there is a resonance, the amplitude of forced vibration becomes maximum. And whenever the frequency of this external force is different from the natural frequency of the body, then the amplitude of oscillation is very small, the amplitude of vibration is very small, and it dies out very soon due to the presence of damping force. Okay, so in the absence of the damping force, if there is no damping force, then the amplitude of vibrations at resonance becomes infinite. Okay, that means amplitude of vibration becomes very large if there is no damping force at resonance. Okay, when the natural frequency of the vibration becomes equal to the frequency of the external force, okay, that time the amplitude becomes infinite. Now amplitude of forced vibrations. Amplitude for vibrations, there is one note, that amplitude of forced vibration doesn't remain constant because of the damping force, okay, of the medium. However, if you want to keep the amplitude of forced vibration constant, then we can do it by applying the external periodic force continuously. Okay, if you use the external periodic force, then it will compensate for the loss of energy, and hence the amplitude of vibration will become constant. Okay, so that we can do it. What are the examples of forced vibrations? First example, if you strike the tuning fork on the table, then what happens, that the stem of the tuning fork starts vibrating. Now this vibrating tuning fork, if you place it on the top of the table, then this tuning fork makes the forced vibrations of the table. Since the area of the table is very large compared to the area of the tuning fork, then these forced vibrations of the table generate large energy, greater energy, and produces louder sound, okay, than the sound produced by the tuning fork. So this is example of forced vibrations. Here the vibrating body, vibrating tuning fork is giving the forced vibrations to the table. Another example is like example of guitar. Okay, when we pluck the string, when we touch the string, or when we pull the string by fingers, then we are making the string vibrate, and these vibrations causes the forced vibrations of the air inside the guitar. So there is air inside the guitar, so whenever we pull the string, whenever we vibrate the string, this vibration of string makes the forced vibrations of air. Okay, and these are the other examples which we can say about the examples of forced vibrations, and you can study the other examples too.